The unit of solution concentration that we use mostly in chemistry is molarity. Molarity we kind of got a little tiny peek of when we jumped ahead to chapter 15. Now we're going to explain what that is. Molarity is often abbreviated with a capital M, and it is defined as the moles of solute per liter of solution. Mass percent was mass of solute per 100 parts of solution. Here we're looking at moles. Chemists are more interested in moles because this relates to particles, and we need moles when we do stoichiometry. So remember that it's liters of solution and not liters of solvent. When we make a solution of specific molarity, we often use a volumetric flask. This, I believe, is a 1 liter volumetric flask, and it's got a mark on its neck. The shape of this is designed so that we can measure volume more accurately. It's got a long, skinny neck so that a small change in volume will cause a relatively large change in the height of the liquid. So we would measure out 1 mole of sodium chloride, which is 58.44 grams, and we would add that to the flask. And then we would add water to mix it. We need to dissolve it all first, and then we add water right up to the mark. And now we know the volume of the solution is 1 liter. You don't take a liter of water and put salt in it. What would happen at home if you had a drinking glass that was full to the top with water and you poured a 1/4 cup of sugar into it? What would happen? It would overflow because the solute takes up some space. And we can't predict how much space it's going to take up. And so molarity uses the volume of the solution, not the volume of the solvent. Calculate the molarity of a solution made by putting 55.8 grams of sodium nitrate into a beaker and diluting to 2.50 liters. Diluting to 2.50 liters. We're adding enough water to make the volume of the solution 2.5 liters. It's not that we're adding 2.5 liters of water. So molarity is moles of solute per liter of solution. Capital M, moles of solute per liter of solution. Which one of those did they give us? Did they give us moles of solute? Did they give us liters of solution? Yeah, 2.50. How do we find the moles of solute? We have to convert. We've got grams, 55.8 grams of sodium nitrate. And we need to find out how many moles that is. So we have moles on the top and grams on the bottom. This is molar mass. So for molar mass, we look at the formula. We've got 1 sodium. 1 mole of sodium would be 22.99 grams. And we have 1 mole of nitrogen, is 14.01 grams, and 3 moles of oxygen, 16 grams. $22.99 plus 14.01 plus 3 times 16 equals 85. $85 grams is equal to 1 mole. Did I do that right? Okay. Because it's always a little unnerving when a molar mass comes out to be a whole number. Calculator just said 85. That makes you wonder. Because usually it's 85 point something, right? So we'll stick that in here. 1 mole of this weighs 85 grams. The grams cancel out. 55.8 divided by 85. 0.65647 moles. Now that would have 3 sig figs. Always good to carry along some extra ones until you're all done. That's moles. So we divide by 2.5 and we get 0.263. The units there are moles per liter. But we also abbreviate that with a capital M, 0.263 capital M. Capital M's, when they're handwritten, can be hard to distinguish from lowercase m's, and so I usually underline my capital M's because I don't want it to look like meter or like a sloppy abbreviation for mole or something like that. Any questions? You guys are singularly uninquisitive today. It's okay, you're tired. Molarity is also a useful conversion factor. So we can do a calculation like this. Determine how many grams of sucrose in the formulas given to us are contained in 1.95 liters of 0.781 capital M. So that's 0.781 molar sucrose solution. So let's write these numbers down and see what we have to work with here. So we've got 1.95 liters, and we've got 0.781. Capital M, write down what it means, because otherwise you'll forget, and then you'll get lost. That means moles over liters. And we could extend this line all the way over there. That looks like a conversion factor, doesn't it? This is a very useful conversion factor between volume of solution and moles of solute. Here's our volume of solution, and they're asking for a mass of sucrose. So our path is going to be liters of solution to moles and then to grams. 1.95 liters. And then I want to multiply by moles and divide by liters. And then I want to multiply by grams and divide by moles. Dimensional analysis strikes again. The relationship between moles and liters is the concentration, the molarity, 0.781 moles per liter. 0.781. And this one here we have to calculate. It's the molar mass. So we've got 12 times the mass of carbon and 22 times the mass of hydrogen and 11 oxygens. 11 times 16. 12 times 12.01 plus 22 times 1.008 plus 11 times 16 equals 342.3. Grams of sucrose, that's equal to 1 mole. That's the molar mass. So that's the number we need for that last term. 342.3. We come up with a mass of 521 grams. Any questions? If you're still shaky on dimensional analysis, it's still worth your effort to figure it out. because there's more of this coming. And yeah, you could learn some formulas for how to do this, but it's going to be hard because there's so many different things that can happen. If you know how the units work, you just put things together to cancel the units out. Any questions? When we have molecular solutes, like that sugar solution we just looked at, the concentration is the concentration of the molecules in solution. When we have an ionic solute, we usually are referring to the concentration of the solute before it dissolves, because when it dissolves, it separates into ions. So if we say 1.0 molar calcium chloride, we mean it's going to have 1.0 moles of this formula unit, calcium CaCl2. When that dissolves, you're going to have 1 mole of calcium ions and 2 moles of chloride ions in every liter of solution. Because when this separates, you get 1 calcium and 2 chlorides. So we can approximate the concentrations of the individual ions. We can't really measure them exactly, because pretty much all chemical reactions go in both directions. They're equilibria. And so a solid dissolving may be highly favored to the ions, but we can't say for everything that it's going to do that. So it is an approximation. Determine the molar concentrations of calcium and chloride ions in a 0.75 molar calcium chloride solution. So 0.75, capital M, means moles per liter. Moles of what? CaCl2, the solute. Well, if we want to know how many moles of calcium ions per liter, we could apply a conversion factor and convert to moles of calcium ions and divide by moles of calcium chloride. How many moles of calcium ions are in 1 mole of calcium chloride? 1. It's just the formula. There's 1 calcium and 2 chlorides in each of these. So this is going to be 1 to 1. And the molarity, the concentration of the calcium ions, is the same as the calcium chloride. What if we want to know moles of chloride ions? Well, we need to figure out how many chloride ions are in 1 unit of this. There's 2. So this is 2 moles of chloride for every 1 mole of calcium chloride. And we'll get 1.50 moles per liter of the chloride ion. And depending on what you're doing with this solution, you may or may not care about this. Any questions? So if you're given a concentration, it generally refers to the entire compound. But sometimes you might be asked for the concentration of 1 or more of the individual ions. And to convert that concentration of the compound, you just look at the ratio of ions to formula units.